Okay, so next on the agenda is learning how to add and subtract polynomials. We have talked about polynomials and you've seen them before, but you probably don't know what on earth that word means, right? So we need to define that. First, we're going to start with talking about monomials. So mono means one, so it's the product of one or more constants and or variables. So we need to write in constants. Just ignore my crazy handwriting on this. Then next we can talk about polynomials. So that's a bunch of monomials being added or subtracted together. So if you look at our examples here on the right, we've got our monomials, which is just one term. So like 5x, or a string of things being multiplied, or y to the third, or just a plain number. Those are all monomials. But when we add them all together, that's when it turns into a polynomial. Okay, so we also have a couple different names. So we said monomial is when we have just one. Binomial, you guys have heard of a bicycle that has two wheels, so that's when we have exactly two terms. So like 5x plus this big thing. And this whole thing is just one term. Okay, just because there's multiple variables does not mean it's any more than one. Then we've got trinomial. You've heard of a tricycle. That has three terms. Okay, so you'll notice our example on the side, we're now subtracting another term at the end. Okay, we also need to talk about the degrees of polynomials. So the degree of a polynomial is the same as the highest degree out of all of the terms in the polynomial. So on our examples over here, let's go ahead and list these degrees. So we've got negative 7y cubed. So the highest degree, or the highest power here, is 3. Okay, and that's of just a term. On 19, there isn't any power, so that's just a degree of 0. Now let's look at this long example. This term right here, our 5x, has a degree of 1. I'm going to skip this big term because that's a little crazy. Our minus y cubed has a degree of 3, and then we said any plain number has a degree of 0. Okay? Now, when we're talking about a degree, we need to make sure that we're adding up all of the powers in that term. So we've got a squared, b cubed, and c to the 7th. So we need to add all those up. So when you add all of this together, you get 12. So the highest degree term out of this whole polynomial is 12. So that's going to be the degree of the polynomial. So now we can talk about adding polynomials. So when we add a monomial or a polynomial, we look for like terms. We've talked about like terms forever. This is just kind of a refresher, and then we're going to lean into some more stuff. So we need to add the coefficients of the like terms together. So when we have 3x and 2x, we're adding together the coefficients. So how many x's do we have? We have 5 x's. Okay, so that's a refresher. We've done that before. Then we've also got maybe different variables. So we've got a 4y minus 3z minus 9y plus 5z. So we need to make sure that we're combining those like terms. So 4y minus 9y is going to be negative 5y. Negative 3z plus 5z is positive 2z. Okay, so I'm just combining my like terms. This is a refresher section. So then you've also got, when you've got an a squared and a b, is there another term that's similar to that? Is there another a squared and b that with a different coefficient? No, there isn't. So we're just going to copy that down. So 8a squared b. Okay, then you've got minus 2ab. Is there another term where it's only ab? Yes, for this one there is. So that's a minus 5ab as well. So we're going to combine those and have minus 7ab. And that leaves us with our last term, which is just going to be our ab squared. And we're just going to add that to the end because there isn't a like term for that. And so that's our combined terms for that polynomial. Now you'll notice in that last one, not all of those terms had a like term, and that's okay. We don't always have to be combining these terms. So now is when we're really starting to add these polynomials. So I've got one polynomial being added to a whole nother binomial. So this is a trinomial here. We've got 3 terms and another binomial being added together. So we need to focus on the sign that's in between them. So for these we're adding, so we know it's going to be addition. So we're going to kind of distribute that addition sign. So we'll have x squared plus 4xy plus 7y squared plus 8x squared minus 13y squared. Okay, so now we just have a string of terms, and now we're going to combine terms that are alike. So we've got x squared. Is there another term that has just x squareds? There sure is, and it's 8x squared over here. So we're going to combine those, add those together. That leaves us with 9x squared. Then we've got 4xy. I'm going to go ahead and cross out these terms that I've already used. 4xy. Is there another term in here that just has x's and y's? There is not, so we're just going to write that one down. Okay, use that term now. And then last we've got our y squared. There's a 7y squared, and there's also a minus 13y squared, so I'm going to combine those, and that would be a negative 6y squared. Use those. So have I combined all of my terms from my big polynomial? Yes, I have, so that's when you can make sure you box that answer. Okay, number 5 is a little bit larger, and that's okay. I'm not going to rewrite it this time because we know it's an addition sign, so I can just follow the signs that are in front of these terms in this trinomial at the end. So I'm going to start with my 4a squared b. Is there another term that has an a squared b? We've got a 9b ab, we've got a 14b squared, but there's no other terms that have an a squared b, so I'm just going to write that down. So 4a squared b. Then I've got my 9ab. Is there another term that are just ab's? There sure is. There's a positive ab here, and that's a coefficient of 1. So minus 9ab plus ab is going to be a minus 8ab. Okay, I've used these terms so far. Now I'm going to keep following in order, so I've got a minus 14b squared. Is there another b squared term? There is. We've got a positive 11. So I've got my minus 14, positive 11. That's going to be a minus 3b squared. Now I'm left with my last term, which is 7ab squared, and that's just going to be copied down because there's no terms left to combine with. Okay, so that's my final answer for number 5. All right, so very similar to addition of polynomials, we're now going to subtract the polynomials. We just need to be really careful with that subtraction sign. So we can kind of think of that subtraction as a minus 1 in front of our second set of parentheses. So we need to distribute this negative to both of our terms. So I'm going to rewrite this first binomial and then distribute my negative to my second binomial. So minus x plus 2. Negative times a negative makes that 2 a positive. And now I can combine my terms. Okay, so 2x, and then I've got a minus x, so that'll just be a positive x. Use both of those. Minus 3 plus 2 is minus 1. So that's my simplified version of my subtracting of those polynomials. Then number 2, we're going to do the same thing. So I'm going to copy down my first trinomial. And I'm subtracting my second, so this negative needs to go to every single term. So minus 4p, my minus 6q is going to become a plus 6q, and my positive 12r is going to be a negative 12r now, or subtracting 12r. Combined our like terms, we've got p's here, q's, and also our r's. So I'm going to go ahead and combine all those. 10p and minus 4p is now 6p. Minus 3q plus 6q is now positive 3q, and then our r's become a negative 7r. And that is our simplified version for that problem.